In this section, we are looking at rolling motion. I have a small task for you guys before I start off with any discussion, any formula, any numericals, any derivation. I want you guys to take a second, take some time, not an issue. I want you guys to observe this. See what you can notice. Test your observation. What is that we are looking at? We are looking at a wheel. Okay, it's a bicycle wheel. And by the way, it's an actual photograph. This is from a book, Fundamentals of Physics. So I have taken it from there. And it's an actual photograph of a rolling bicycle. So if you have observed it carefully, the blurriness. Okay, so it's a long word actually. As in when you move up, the blurriness, it increases. Can you see that? It increases. At the bottom, technically, it has to be zero blurry. So can you see that the picture is quite clear over here compared to this? So you can see that the spokes over here is a lot more clear than over here. Here it's almost not visible. Here it's quite visible. Here it's decently visible. Here it's less visible. But it's kind of there, you can make out. Here it's as if it's almost not there, it's just white. The presence of the spoke have disappeared. So if you move up, the blurriness increases. And it's an actual photo. It's this, and you can do it with any wheel. We'll end up with this photo. If you take up any traffic pictures, if you take up any F1 wheel, F1 photos, I'm sure all of them will be with good camera, the photos that is. And here the same thing can be observed. At the bottom, the wheel near the ground will be less blurry than the wheel above the ground. You need to observe that. And yes, we will discuss this mathematically. We'll prove this mathematically actually. It's not very complicated, but it's, when I saw this, when I was a kid, when I saw this, I was like, seriously, is this possible? That's nature, It is a bit weird, but that's how it is. So this is an image taken from this book, and against the photo, the text read as a photograph of a rolling bicycle wheel. The spokes near the wheel top are more blurred than near the bottom because of the top ones are moving faster. So this is something that I'll prove it to you guys. This diagram I can't show. So this is thanks to the book Fundamentals of Physics, 10th edition. Okay, so this is what we are studying in this section. Okay, that's the agenda to understand this. Now, we are looking at rolling motion. Forget about that picture. We'll just look at rolling motion. Rolling motion is quite complex actually. So let me show this. I have rolling motion, yeah. So this is a rolling motion. So what you have to observe over here is, before I start actually, that's a wheel that is about to roll. There's certain condition that it has to satisfy, only then we'll consider it to be rolling and all of that. So you have the wheel, the green color indicates the center of mass, and the red is a random point on the circumference of the wheel, basically. Now, the video follows those points as and when the cylinder rolls or the wheel rolls. Okay, so it's following. Can you see that? What can you observe? Center of mass, how is it moving? It's linear. It's moving on a straight line. While the points on the circumference of this wheel, it is forming something called as cycloid. It's quite complex actually, So looking at purely rolling motion, just rolling motion is quite complex. So what do? To ease into this topic, we consider the combined movement of the object like a wheel or a ball, simultaneously translating and rotating. So we look at the entire thing as combination of pure rotation and pure translation. So let me put that across to you guys as a picture. So say this is pure rotation and pure translation. So let me give myself some space. I think that's good enough. Okay, let's do this. So this is the ground. Right? Again, this is the ground. Almost touching. And this is pure rotation. And this is pure translation. Okay. So basically, this being your center of the wheel, center of mass, basically, the entire thing is rotating with a velocity of omega. Say this is a point P. Okay, you guys can't see that. So this is point P and this is point P. And the top, we'll call this as T. T, and our kind of have to mark the center. Somewhere around there is a center. So we're looking at all of these points. So that's point P for us. P, and this is T, and T. Okay, as a pure rotation, right? If I take omega as your velocity, angular velocity and stuff, at point P, okay, remember it's rotating, this is clockwise. At point P, at the point P will go to the left, the point T will go to the right. Okay, so at point B, the wheel will go to the left, and point T, the wheel will go to the right. So the velocity over here is minus V, and here it would be V. You guys agree? This will be positive and this will be negative. Now, over here, pure translation. Okay, let me show you guys pure translation. So rotation is pure rotation. Remember, it's just running over there. It's at one point and going round and round. In pure translation, it would be this basically. Okay, again, we are considering the point at the top, the center, and the bottom. Imagine that we are considering all the points. Since it's pure sliding or pure translation, it would be something like this. So every point will have same or different velocity. Yes, they will have the same velocity throughout. So whatever velocity we see over here, the same thing will be seen over here and everywhere. So velocity of center of mass, and so on and so forth. Here I have written velocity of center of mass, but I didn't explain why. I just wrote, I can just write it as V1 and V1. I need not write this as any other value. We'll see the math a bit later. So let me write V1 and V1. Let me not confuse you guys. So this is V1 and this is minus V1. Okay. Right. So this is the scenario. The combination of this would be your correct rolling motion. So I'm combining this two. Let me change the color. This will lead to rolling motion. Remember, it's a combination of this. Now, what will happen? All of this we need to add with vectors. Okay. So basically, if I add the T at the top, we'll end up with what? We'll end up with V1 plus V center of mass. At the center, this is 0 and this is V. V center of mass. Again, I'm just adding velocities, guys, nothing fancy. I'm not doing anything fancy. And over here at point P, we might have some velocity, but it would be a difference of V com minus, sorry, not arrow, minus V1. You guys agree? So this would be the case. At point T, the velocities are adding up. At point O, there's one is 0, the other one is, it's not moving, right? Because it's pure rotational. So the center of, the axis of rotation is around the, through the center of mass. So it's not moving. It's not rotating basically. So 0 plus any value is the same value, additive identity property. And at the bottom, that point P, the relationship is negative. So they're subtracting each other. If the V1 value is equal to V com, then they will cancel each other out and we get 0. So point is that we can understand pure motion, pure rolling motion with the help of pure rotation plus pure translation. That's the whole point. So please don't get confused with anything else. It's just that rolling motion we are understanding over here with the help of pure rotation, pure translation. If you didn't understand whatever written over here, actually you should be able to. It's not that complicated. If you're confused with the velocity, I'll explain it again. Pure rotation as of now, I'm taking it as V1 and V1. That has to be the same because the entire object is going round and round with the value of omega. Point P and point T are at the same radius distance, at the same distance away from the center. So the velocity has to be same, right? V1 has to be equal to this V1, but the directions are opposite. So this one is minus and one is plus. When it comes to pure translation, you can see this, what is happening. So object is just going straight to the right, straight right or whatever direction it is. But the point is all of them will have the same velocity as that of the center of mass. So all of them have the same thing. Now when we combine this two, we'll get rolling motion. And I'm just using vector addition to add them up. Okay, this will be doing it in detail. This is just an introduction. Just to tell you guys that rolling motion is complicated. That's all the point is. It is complex. To ease into this, we will use this methodology is what I'm trying to introduce, nothing else. Okay, and that's it. Okay, so this is a very interesting thing. Actually, you will be able to understand this with the help of this. Think about it, it's not too hard. Welcome to rolling motion. This is where all of the things that we have learned from day 1 of 11th grade syllabus, it's adding to. Just the wheel, one of the most important invention of human civilization. We're trying to understand that.